Morning, dear students. So as we have already started differential equation in the previous lecture, and I have explained you the meaning of differential equations, and I also taught you that what are the differential equation, what is the order of the differential equation, and the degree too. And we have seen that in the second exercise, that how can we show that the given solution is a solution of particular differential equation. Alright, so if we differentiate the solution, then we will get the particular differential equation. Now we are going to see the next topic, that is formation of differential equation. Okay, so what is this formation of differential equation? Now you need to formulate it. Okay, how we will formulate? So consider the general equation. Say for example, if we have a general equation, y is equal to ax plus x square. Say for example, I'm just taking this that means it is not a general equation, one example I'm taking. Okay, so you need to make the differential equation with the help of this equation. So what things you have to remember, that we need to eliminate the arbitrary constant here. You know what is arbitrary constant? Here a is the arbitrary constant. Okay, now why we are eliminating arbitrary constant? Because the formation of differential equation means to form the differential equation by eliminating arbitrary constant from the given equation. Since each differentiation yields a new equation, the number of derivatives that need to be used equals the number of independent arbitrary constants to be eliminated. Okay, so therefore the required differential equation is obtained by eliminating the independent arbitrary constant from them. Are you understanding? Okay, so in this way we obtain an ordinary differential equation by freeing up the equation by the arbitrary constant. So say for example, if this is the equation and I need to just form a differential equation, so I'll just differentiate it. So while differentiating, this will give me a plus 2x. Okay, now take 2x that side, so dy dx minus 2x will be equal to what? A. Now in this particular equation, just put the value of a here. So y will be equal to dy dx minus 2x into x plus x square. Now multiply x inside, so y will be equal to x dy dx minus 2x square plus x square, or finally we'll get x dy dx minus of x square. So this is what the differential equation of degree 1 and order 1. So like this, remember, we need to eliminate the arbitrary constant from our equation. Okay, so let's get started with this exercise number 9.3. Let us do the questions. But before that, one very important remark I just want to let you know, that if in the equation, if you have one arbitrary constant, then the order of that particular differential equation will also be 1. That means you will get a one order differential equation. If your function has two arbitrary constant, then on solving or while formulating the differential equation, the order of that particular differential equation will be 2. Are you understanding? Say for example, I have the equation, y equal to mx. This is the differential equation I have. This is the equation which is I've taken from the family of straight lines. Okay, so now here I have one arbitrary constant, that is m. Let us differentiate this. So dy dx will be equal to what? M. Now in this equation, just put the value of m here. So y will be equal to x dy dx. So this is what the differential equation of this. So as I told you, here you have only one arbitrary constant, so the degree of this differential equation becomes 1. Now say for example, if I would have taken y is equal to mx plus c, where m and c are the arbitrary constant. Okay, so what I told you, you will get a 2-degree equation. So let us see, are we getting or not? Just keep in mind, we need to eliminate the arbitrary constant. Okay, so it will be dy dx will be equal to m, okay, plus c, it will be what? 0. So your dy dx is equal to what? M. So in place of this m, we can put what? Dy dx, and we need to replace this c also. So how can we replace this c? So no worries, see, y dy dx and m. Now we need to c is already eliminated. Now we need to again eliminate what? M. So you differentiate again, so it will be what? 0. So this is the differential equation of this particular family of straight line. Okay, are you understanding? I told you m and c, 2 arbitrary constants, so the degree of the differential equation will also be 2, so hence proved. So like this we understand. Okay, now say for example, if this is the question where y is equal to e to the power mx, where m is the arbitrary constant. Now you would be thinking that how can we eliminate m, because we need to eliminate the arbitrary constant whole from this equation. So even if you directly differentiate, we'll get e to the power mx into m, where the m has removed. If you again differentiate, again it will be m square, and the power of the m will increase, and it will not eliminate the arbitrary constant. So what we do to take this mx down, we'll take log both sides. So log y equal to log e to the power mx. Now take mx down by the property of logarithm, so it will be log e to the base. Now we know log e to the base e, it will be 1, so I'm removing this. Now you differentiate both the sides. So 1 upon y dy dx is equal to what? M. So we got the value of m as 1 upon y dy dx. Now if you are thinking that we can put the value of m here, so have you seen anywhere that e to the power 1 upon y dy dx comes? No, right? So what we are doing, we are just putting the value in this step. Why? Because if we will put m, then this dy dx will come this side. So your differential equation will be in the proper form or proper way. Okay, so on putting log y will be equal to, in place of m we can write 1 upon y dy dx into x. Moreover, you can take y that side, so y log y equal to x dy dx, like this. Okay, now let us come to the next question. See, this is very important question, or you can consider that you will see some new thing in it. You are having y equal to a e to the power 3x plus b e to the power minus 2x, where a and b are arbitrary constant. Now see, don't see the solution first, listen to me. See, you have 2 arbitrary constant, and if you directly differentiate, there is no chance that these 2 will get eliminated. So we need to use some other logic in it, and that logic says that as you have e to the power minus 2x, which can be written like this, and on taking the LCM, e to the power 3x into e to the power 5x, it will give you e to the power 3x into e to the power 2x, it will give you e to the power 5x, and this b will be alone. Okay, be it in the denominator, so we can take this here, y equal to e to the power 2x, and here a e to the power 5x plus b. So what among these two, I somehow made any of them as alone, so that on differentiating this could be eliminated easily. Okay, so you need to build up the logic which should help you to eliminate any of the arbitrary constant. So here this logic has worked, okay, and we got the answer with this logic. So you need to just you need to think like that. Okay, now differentiate both the sides with respect to x. So y e to the power 2x will be 2 into e to the power x, e to the power 2x plus e to the power 2x as it is. Y differentiation is dy dx equal to, differentiate this, you'll get 5a e to the power 5x. Now take e to the power 2x common, so you'll get 2y plus dy dx is equal to 5a e to the power 5x. Now again you differentiate with respect to x. Why? As I told you, two arbitrary constant, so you'll get a hint that you need to differentiate 2 times, then only you'll get the exact answer. Okay, so differentiate. I've taken this 2 as functions, so this as it is. On differentiating, 2 dy dx plus d2y dx square, plus keep this as it is, e to the power 2x, you'll get 2 into e to the power 2x. And here 5 I have written as it is, a e to the power 5x will be 5 times of a e to the power 5x. Now again see, this is also having e to the power 2x, e to the power 2x, again I took common. So this one as it is, and here multiply 2 inside with these two, so you'll get here like this, 5 as it is. In place of 5a to the power a e to the power 5x, I have a value here. So here see, I'm replacing this with this one. Okay, so e to the power 2x and 2y dy dx. Now as you can see that e to the power 2x to e to the power 2x we can easily cancel. Then comes what? See, 2 times of dy dx, 2 times of dy dx will get 4 times of dy dx, plus this d2y dx square I'm writing front. Just write properly, plus this will give you 4 dy dx, then plus of 4y, then 2y plus dy dx. Take all the things here. So wait, 5 is also multiplied inside, no? So it will be 10y and this will be 5y. Okay, take 10y here and 5 dy dx here. So your answer will be d2y dx square. If you'll take this one, so it will be minus dy dx, and if it will come here, so you'll get minus of 6y equal to 0. So this is the final differential equation. Okay, so this is how you have to use the logics. Okay, let us come to this question. So here it is given that y is y e to the power x a cos x plus b sin x. This was the question. So y is equal to, I have multiplied e to the power x inside like this. So as 2 arbitrary constant, so this, the solution or the differential equation will take us to the second order derivative. Okay, differentiate y dy dx. Okay, and here I have taken a out, this 2 functions, so putting e to the power x as first function, cos x minus sin x, plus e to the power x cos x, plus b taken out, and here I have multiplied the a and b inside, so these two a and these two b from these two. Okay, now as a e to the power x cos x plus b e to the power x sin x is nothing but y, so in place of this both I have written y, and these two here as it is. Okay, so keep this as it is. Now you differentiate this only. Okay, so it will be d2y dx square. Here you need to again use the product rule. So I have used the product rule also and multiplied minus a inside with both. So minus a, see, e to the power x sin x will be what? E to the power x cos x, minus, keeping this as it is, e to the power x is e to the power x and multiplied minus a inside, so these two. Similarly for this b, it will be minus of b e to the power x sin x, because cos x is minus sin x, so that is why minus came. And next one will be as it is, plus this y will be what? Dy dx. Now from these two I've taken minus common, so I got a e to the power x cos x plus b e to the power sin x, which is nothing I can write from here as y, and this here and this one here, and dy dx. But as you can see that minus a times e to the power x sin x plus b cos x, if I take plus y that side, so will it be minus y equal to, so in place of this what we can write? Dy dx minus y. Okay, so that this will also be eliminated and this will also be eliminated, and which will finally eliminate both the arbitrary constant, and we'll get the final differential equation. So dy dx d2y dx square minus of y and in place of this we can put dy dx minus y and plus of dy dx. So finally minus y will get plus of 2y. So the differential equation will be d2y dx square. Take the dy dx plus dy dx, so it will be minus 2 times of dy dx, and minus y plus 2y, so plus equal to. So this is the final differential equation. Okay, now listen to me very carefully. After 12th question, that is what form the equation of curves and this concentric circles, find the differential equation of the following family of the curve. This you don't have to do because they are the excluded questions. Okay, because you don't have to solve the differential equation which is including the coordinate geometry, okay, or the application part. So we need to exclude those questions. Okay, so I hope you understood the today's lecture. Okay, try to do this exercise. We'll come up with the next exercise in which we'll be dealing with solving a differential equations. Okay, there are certain forms which we will understand. All right, so do practice. Have a good day. Bye bye. Thank you.